My name is Hyun Gu Kang. I'm in grade 12 and I go to school in the downtown core. So as Ashley mentioned, I think Ashley's exact words were "math is gross." That was the reason that I wrote this piece. The reason that I wrote this piece is actually kind of embarrassing. The contest asked for an entry in creative nonfiction, and I had no idea what that was. So I took the most nonfiction thing I could think of, which was math, and I tried to turn it a bit creative. So here we go. My littlest sister once compared math to a wicked, multi-purpose Swiss Army knife. I laughed at the time, but the more I consider her words, the more truth I see in the comparison. In its own way, math is a compact, reliable, and relentlessly practical multi-purpose tool. It is flexible, honest, and at times even elegant in its simplicity. Math is beautiful, math is productive, but most importantly, math is the most human alternate reality that I know. I describe the math world as an alternate reality because, even though it exists only in our collective consciousness, it is vast enough to contain a theoretical model of the universe. Although it may not seem evident at first, math consists of the same kind of matter and energy that the universe does, albeit in idealized, theoretical form. The universe is populated by matter, antimatter, and particles that we are just beginning to detect. It develops through the interactions between four principal forces: gravity, the electromagnetic force, the strong nuclear force, and the weak nuclear force. The evidence that we have collected thus far indicates that our universe is expanding, and that it originated during a spontaneous explosion of energy that we call the Big Bang. Similarly, the math world is populated by numbers. There are natural numbers, integers, real numbers, rational numbers, and complex numbers that exist not on a number line, but on a Cartesian plane. While the physical universe is limited to four forces, the math world is acted upon by several operations, best encapsulated by the elementary school acronym BEDMAS. Unlike the physical forces, the mathematical operations of BEDMAS correspond perfectly to the dimensions of the math world. Addition, the simplest operation in math, is math's first dimension. Multiplication, a function that measures the amount of times a number is added to itself, is the second dimension of math. Exponents measure the amount of times a number is multiplied by itself, and they constitute the third dimension of the math world. Another way in which math surpasses our physical universe is in the number and variety of parallel universes contained within mathematics. Just as biology, physics, and chemistry are different branches of science, trigonometry, algebra, statistics, probability, and functions are distinct disciplines of math, complete with their own units of measurement, preferred variables, and strategies for successful navigation. Math owes much of its intrinsic beauty to the interplay between these parallel universes. Each mini-math world is distinct but far from self-sufficient. Algebra is used to find the roots of polynomial functions. Sinusoidal functions are visual translations of common trigonometric relations. The intricate codependence of the math universe, like the network of microscopic cells that make up the human body, is mesmerizingly beautiful for both its seemingly impossible complexity and its truly remarkable originality. By weaving the independent math universes into a cohesive mathematical world, humans have created a mind-bogglingly expansive, sophisticated, and beautiful alternate reality that accurately represents the patterns of the physical universe. In addition to beauty, math has the added advantage of practically unlimited applicability. From math comes a plethora of diverse, independent expressions of the human experience, including music, dance, architecture, and technology. I was lucky enough to have received a musical education when I was small, and I remember the amazement I felt when sight-reading Beethoven's Furlies. The only reason we can experience classical music today is that it has been notated for us. The only reason that music has been notated is that composers made the connection between the numerical organization of math and the hierarchical order of sound. By applying mathematical principles to the world of tone and rhythm, musicians like Bach were able to preserve their art for centuries. This is just one example of the ways in which humans use math as a tool to create seemingly more human fields in art and science.